Hello, Jai Hind to everyone. My name is Dr. Sunil Kumar, working as a professor in IT department in AKGEC Ghaziabad. Today, I am going to discuss Q data structure, and basically Q is a non-primitive linear data structure. Non-primitive means that is derived from the primitive data structure, and linear means the data can be accessed in a linear way. In Q data structure, always insertion is deletion from one end, that is called rear end, and deletion is done from the other end, that is called front end. That means we have two pointers, one is rear pointer and another is front pointer. Front for deletion and rear for insertion. And basically it works on the principle, or you can say mechanism, that is called FIFO, first in, first out. This can be understood with the help of this example. Some pupils standing in a queue for movie tickets. In this case, the person is standing at the front will get the ticket first, and then next, and then next. And in that way, it will be done. It can be understood in a better way with the help of this example also. And in this case, we have an array of size 7. How to find out the size? Upper bound minus lower bound plus 1. That is, it is of size 7. And this array contains total 6 elements. First one is 1, second one is 11, 15 and so on. And we are starting index from 0 to 6. We use two end, that is front and rear. Front indicates the position of front element and rear indicating the position of the last element. About the operations, we can perform these operations on the Q data structure. One is add, or we can say insert, and that is NQ. That means we are adding an element in the given queue, and that will be done at the back end. That means that will be done at the rear end. Second one is called remove. That means we are deleting an element, and always deletion will be done from the front. Another operation that is called peek. This operation is used to find the, or you can say to examine the element at the front. Always it will display the value that is at the front. Another operation is empty. Suppose Q is empty and we have to find out whether it is empty or not. With the help of this operation, we can find out whether Q is empty or not. That means there is no element in the given queue at that time. Is full to check whether all the positions are occupied or not. That can be checked with this operation, that is full. And last one is display. That is used to display all the elements existing on the queue at a particular time. We are performing number of times, for example, adding and removing, or you can say NQ, DQ, and at any time we can display the elements, whatever queue existing at that time. Now we are going to discuss elements of queue. As I told you, we have two end, one is called front end and another is called rear end. Insertion always done from the rear end and deletion always done from the front end. Now, whenever we are deleting an element, that is done from the front end, initially we are putting this pointer, that is front, is set to -1. That means there is no element. And whenever we are deleting an element, then always the value of front end is incremented by 1. On the other hand, rear end, whenever we are inserting an element, then always will be done from the rear end. Initially, the value of rear is set to -1. Whenever we are inserting an element, then the value of rear pointer is incremented by 1. This can be understood with the help of this example. For example, we have an array and already we have these elements. For example, these elements are A, B, C, D and E. And in that case, front will be 0 and rear will be 4. So always, if we are trying to delete an element, so first of all, A is deleted. In this case, the value of front will be incremented by 1. For example, we are trying to delete this element. In this case, front will be incremented and front will come here. And if we are adding, then in that case, if all the positions are occupied, then insertion cannot be done, and that will be the condition of overflow. Now, how to check the condition of overflow? Now, because we have the 2 pointers, rear and front, if the value of rear equal to size minus 1, that means all the locations are occupied and size is the size of the array. That means no more element can be added onto the given queue because all the locations all are fully occupied. This can be understood in the better way with the help of this example. For example, size of the queue is 4. Then this is the index, for example, 0, 1, 2 and 3. In size is 4. Now here all the here array is already fully occupied, then no further element cannot be inserted. Here value of front is 0 and rear is 3. How to check whether queue is underflow or not? If this condition occurs, that is front equal to rear equal to minus 1, that means there is no element. Here front equal to 0 and rear equal to 0. Sorry. Initially, front equal to minus 1 equal to rear. Initially, the front and rear will be minus 1. That means this condition. And if there is no element and if we are trying to delete an element, that is the condition of underflow. Now, there are different types of queues. That can be a simple queue or you can say linear queue, or generally we are calling this queue as a queue, and that other variations are circular queue. In this, the rear end connected back to the front end. And what is the need of? I will tell you in the coming slides. Another type is D queue, that is double-ended queue. In the double-ended queue, insertion as well as deletion can be done at both ends. Normally, in the simple queue or we can say circular queue, insertion always done from the rear end and deletion done from the front end. But in case of DQ, that is double-ended queue, insertion as well as deletion can be done from the both end. And another type is priority queue. In this category, along the element value, always they are given the priority, and according to the element's priority, elements can be added as well as deleted, or you can say removed. Now we are going to discuss each one by one. About the implementation, always as we know, implementation can be done by using the concept of array, that is a linear data structure, and by using the concept of linked list, that is a dynamic data structure. We will discuss both of them. Now, first of all, we are going to discuss array implementation of queue. And before going into detail about implementation, we will discuss one example. Initially, in this example, because there is no element, or you can say queue is empty, the value of front is -1 and rear is also -1. And we have taken the size of array is 5. Now, suppose we are inserting a value that is, for example, capital A. Now, in that case, always insertion is done from the rear end because there is no element. Then A is inserted here, and always because it's the first element, then front as well as rear will be updated by +1. Then in that case, front will be 0 and rear will be 0 when we are inserting the first element. Now in the next step, for example, we are trying to insert a new value that is capital B. Now in this case, always insertion will be done at the rear end, then B is inserted after A. Now in this case, only the rear value will be updated, front will be as it is, that is 0, and that is 0 plus 1, rear will be 1. Now for example, we are inserting C, then in the same way, C will be inserted after C, and in that case, rear will be 2, that is this one, that is rear. R means rear, that will be 2, and this is front, that is 0. Now for example, we are trying to delete an element in the given queue. We have 3 elements A, B, C. Now first of all, A will be deleted, and after deletion, the value of front, that is 0, will be incremented by 1. That means it will be 1. And rear will be as it is. Now for example, we are deleting one more value. In that case, B will be deleted and the front will be incremented by 1. That is 1 plus 1, that is front will be 2. For example, we are deleting one more value, that is C. In that case, front will be 3 and rear will be 2. Here Q is empty because there is no element. Now entry point is called rear and exit point is called front. One more example to understand this Q concept in a better way. Initially, front equal to rear equal to -1. That indicates Q is empty. And here we have taken again the size of array is 5 and front equal to rear equal to -1. Now suppose we are trying to add a value that contains 10, then in that case 10 will be inserted here, and in that case both will be updated, that is front equal to rear equal to 0, because initially -1 always when we are inserting first element, the both will be incremented by 1. Then in that case front and rear will be, that is 0 and it is also 0. For example, we are trying to add new value that is 20. In that case 20 added be here and rear will be updated. That means rear equal to 1 and front equal to 0. Suppose we are trying to add another value that is 30. In that case front is 0 and because we are inserting, then rear will be updated, that is 1 plus 1, that is 2, because here rear is 1. Suppose we are trying to add new value that is 40. Again new value will be inserted at the rear end, then front value will be as it is, that is 0 and rear will be updated by 1, that is 3, because here in the okay, suppose we are trying to add new value that is 50, then in that case 50 added after 40, then here front will be as it is, that is 0 and rear will be updated by 1, that is 4. Again, for example, we are trying to add more value that is 60, but that cannot be added because this is the condition of overflow, because front equal to rear plus 1. Sorry, rear equal to front plus 1. Now suppose in the given array, that is this one, we are trying to delete, and first of all 10 will be deleted, then after deletion of 10 front will be incremented by 1, that is 1, and rear will be at the same, that is 4. Suppose we are trying to delete another value that is 20. In that case front will be incremented by 1, that is 2, and rear will be as it is, that is 4. Suppose Now we are trying to delete 30. In that case, front will be 3 and rear will be 4. Because whenever we are we are removing, then in that case, front will be incremented by 1. Again, suppose we are trying to delete this one, 40. Then in that case, front and rear will be same, that is 4. Now suppose again we are trying to delete this 50, then in that case 50 will be deleted, and in that case front equal to rear will be -1. That is indicating the condition of, that is, Q is empty. And suppose if we are trying to implement one more delete operation, that will be the condition of underflow, because there is no element for the deletion, and this is the condition how to find out whether Q is empty or not, that is front equal to rear equal to -1. Now we are going to discuss about the implementation, and before coding we will discuss the algorithm for the insertion, then for the deletion, and then for the display, that is displaying all the elements at a particular time in the given queue. Now the first one is for the insertion. That means we will trying to insert or adding a new element in the given queue. So whenever we are trying to insert a value in the given queue, we will check for the overflow. How to check it? If value of rear equal to size -1, size is the size of the given array. If this pointer, that is rear end, is equal to size -1, that means all locations, all positions are occupied, and this is the condition of overflow. That means there is no space for inserting a new element. If this condition is not true, then we will come to the else part. So first of all, whatever element we are trying to insert, we will read the value of that item, whatever value we are trying to insert. Then before inserting at the rear end, we will increment rear by 1, that is rear equal to rear plus 1. And always insertion done at the rear end. For example, this is a queue. Initially rear equal to front equal to -1, that indicating, for example, there is no element. So first of all, for example, we are inserting element here. Then always, first of all, we will increment rear by 1, that is rear will be 0. That means if we are indexing from 0, 1, 2, 3 and 4, in that case that rear is 0. But because this is the first element, we have to maintain the value of front also. If front equal to -1, that is -1, in that case front will be front plus 1, that front equal to rear equal to 0. And finally, insertion will be done in the given queue. This algorithm for deletion, or we can say we are trying to delete an element from the given queue. Before deletion, always we check whether there should be one element in the given queue, because if there is no element, we cannot delete. So how to check it? If the value of front pointer is -1, that is equal to -1, that is comparing, that indicating queue is empty. As we have taken the example, for example, this is the queue. These are the position where we can insert the element. We are doing the indexing from 0, 1, 2, 3 and 4. Initially, front equal to rear equal to -1. That indicating there is no element. Because there is no element, then that indicates it is empty. If it, and we will come. First of all, for example, we have this situation. We have 3 elements. In that case, front value will be 0 and rear value will be. If we are deleting, then always deletion from the front. In that case, A will be deleted, and in that case, the value of front pointer will be incremented by 1. That is, in that case, F will be 1. that is front equal to front plus 1. And always Q is a array and always deletion will be done from the front. Now we have done insertion and deletion number of times. At a particular time we want to check how many elements exist onto the given queue. Now first of all, for displaying at least one element onto the given queue, how to check it? If front equal to -1, as we have discussed, if this is the condition, front equal to rear equal to -1. Okay, now we are going to discuss algorithm that is used for displaying the element from the queue, or we have applied number of times insertion deletion, and at a particular time we want to check what elements exist onto the given queue. Now in this case, if front equal to -1, that means if this condition happens, that means there is no element, and in that case simply we will display this message that is queue is empty. Because there is no element, then we cannot display anything. If this condition is not true, then we have to display all these elements. So always display will be done from front to rear. Now for example, for that purpose we use a for loop, and for loop, for example, for loop we are using a integer I, and that will be taken from front to rear. That means in that case the value of these queues will be printed. First of all, A will be displayed or printed, then B, then C, and then D. And whatever value I will contain, it will print that value in that order. Now these algorithms, with the help of these algorithms, that can be implemented in the programming, and I'm going to discuss this program that is for implementation of queue using an array. Now already we are familiar with this library, that is stdio.h, that is standard input output. Already exists the library, and here we have taken the array size as 4. That is, we have defined size 4, and here we are applying different operation. One function for inserting an element onto the given queue, another word for deleting an element from the queue, and if we want to display at a particular time, that function is used, that is display. We have taken a variable of integer type, and initially we have defined front equal to -1 and rear equal to -1. These front -1 and rear -1 indicating that means initially there is no element in the given queue. One variable, that is item, that will be used for insertion purpose. We are using a switch function, and we will put the choice. For that I'm using this variable, that is choice. We have taken an queue array, and size that will be taken by from this variable, that is 4, and from here we are using, that is, every program has a main function. This is statement already, that is after number of times running the program, all the output will be cleared, and for this we are using this, so that current output should be shown. We are using while 1 because this is a menu based program. We are putting the choice 1 for insertion, choice 2 for deletion, choice 3 for displaying the element. So this is the menu: 1 for insertion, 2 for deletion, 3 for traverse, visiting each element exactly once. If we have done all the choice, then for program exit, we will use this, that is choice 4. If you are putting another choice, that will be the wrong one. For example, initially we are writing enter your choice. From choice you can enter from 1 to 4. Then simply we have scanned that value, whatever choice we are giving. Then we are using this switch statement, case 1 for insertion, and we are using here break statement. That means after inserting a value, it will come out, and again it will demand the choice what operation you want to perform, unless we are putting the choice 4. And case 2 for the deletion, case 3 for displaying, and case 4 exit. And if we are putting another choice, that will be the wrong choice. Now the first part, this segment, this one, that is for inserting or adding an element in the given queue. In that case, already we have defined a function that is insert. We will call that function. And as we have discussed in case of algorithm, whenever we are adding or inserting an element, always we have to check for the overflow condition. So how to check it? If the value of rear equal to size minus 1, that means we can take an example. For example, this is the given queue, and if all the positions are occupied, and in that case, the front, for example, indexing, we are starting from 0, 1, 2, 3, and 4, sorry, 3, then front value will be 0 and rear value will be 3. Now here all the positions are occupied, and in that case front, sorry, that is rear equal to size minus 1. So here size will be taken as 4, then rear equal to, that is size 4 minus 1 equal to 3. That means rear will be equal to size minus 1. That means there is no position, no location to insert a new element. In that case, simply we have to print this message, that is queue is full. No more element can be added at that time. If this is not true, that means we will come to else part. First of all, we will enter the value which we are going to insert. For example, we are going to insert some new value. Then we will scan that value. Then before inserting, always we are incrementing the rear point. That is rear equal to rear plus 1. And after that, in the queue, at the rear point, some element will be inserted, or we can say added. Because this is the first element in the given queue, we have to check for the front also, as we have discussed in the algorithm. If front equal to minus 1, if it is the first element we are going to insert, then front is also incremented by 1. That is front equal to front plus 1. Now this is the second operation that is used for deletion, and whenever we are deleting an element, always we have to check underflow condition. How to check it? If front equal to minus 1, that means there is no element in the given queue. In that case, we have to simply print this message, that is queue is empty. If this condition is not true, then we will come to the else part. That is, first of all, we will delete an element. For example, we are calling that element as an item, and we are deleting from the queue, and deletion always will be done from the front. And after deletion, as we have discussed in the algorithm, the value of front will be incremented by 1. And this is the simply message, that is deleted the item from the queue is, the value will be printed, what value we have deleted. And this is the third one, that is for displaying or printing the values on the given queue at a particular time. In case of display, first of all, some element should be exist on the given queue. How to check it? We have taken a variable I that is of integer type. If front equal to minus 1, that is indicating there is no element. If there is no element, nothing to display. In that case, simply we have to display message, that is queue is empty. If this condition is not true, then we will come to the else part. Then simply we are printing a message that elements in the given queue, and as we have discussed in the algorithm, we will using a for loop with the help of a variable, for example I, and I equal to front. That means we have to print from A to D. That is, first of all, it will take front, and condition will be I less than equal to rear, and always I will be plus plus. In that case, if we are running this, it will be this one. First of all, A will be printed, then B, then C, and then D. That is from front to rear. And then whatever value I will contain, it will print that value